I said on my slideshow that the JDK comes with a program called a compiler, which will turn your text source code into a compiled class file. And then the JRE, the Java Runtime Environment, comes with the Java Virtual Machine, the JVM, and it's like a simulation of a CPU that can run your compiled class file and actually make your program go. That's kind of hidden from you by the IDE, because within an IDE, when you press the play button or whatever, it appears like your program just runs. But what your IDE is actually doing is it's running these other two programs that are separate from the IDE. Specifically, the compiler for Java is called javac, and the program that runs your JVM is called Java. And you can run these programs yourself outside of any IDE at all. And that's kind of a fun thing to do at least once. And so that's what this video is going to do. It's going to walk you through the process of how you can write a Java program without an IDE and then compile it and run it. So the details of what we're about to do are slightly different depending on what operating system you're using and what software you have installed. I'd like to try and do something that's kind of relatively neutral and will hopefully be similar to your own setup at home. But what it means is that if you're a Windows user, you have to download and install a program called Git for Windows. I'll show you what that looks like in just a second. For Mac people, what I'm going to do here, I believe, should work on a Mac. I'm going to have hopefully our TA, whose name is Sriganesh and who is awesome, record his own video on a Mac, or at least verify that this works on a Mac. But if you're on a Mac and you discover that this doesn't work, please throw something in the comments just to let the rest of us know. So before I launch into the first version, Windows users, this is what you want to download. You search for the phrase Git, G-I-T, for Windows, and you want to download and install this program. It comes with a very nice terminal called Git Bash. Okay, so here we go. If you're in Windows and you've installed Launchy, you can type GIT and you see it says Git Bash, and that will launch the terminal. Otherwise, you can search for it down here. Again, type GIT and you can run Git Bash. Let me make the font a little bit larger so we can see. So this is a command prompt similar to the one that you used when you were checking your Java. Again, you can check Java here by saying java-version, and it will show you the version of the JRE that you have. You can type javac-version, and it will show you the version of your Java compiler. If you want to know where these are located, you can use the command which. So I can type which Java, and it will show me the path. It looks like right now I have a 32-bit one. Which javac, it looks like I have a 64-bit one. Interesting. Okay. Just as a reminder, if you were in Windows, the ordinary Windows terminal, you can't type which, you have to type where, but that does the same thing. Okay, great. So from the command line, we're actually inside a particular folder right now, but there's no indication which one. So you can type pwd for print working directory. Directory is another name for folder. So it says that I'm in my C drive in the users folder inside D. Dobrovich. You'll notice that there are forward slashes here, which is the convention for Macs and also for Linux. It's a nice convention. PCs use backward slashes, but because this is trying to emulate a Linux-like environment, it's using forward slashes. So if I want to see what files and folders are inside my user folder here, I can type ls. That's not a 1, that is an L. ls, which stands for list, and it will show me a list of all of the folders and files. This is the same view that you would see if you opened it up in your file explorer like this. So you can see here I'm inside my C drive users D. Dobrovich, and it starts with these folders that start with a dot. These are typically called hidden folders because they're hidden, but I've configured Windows to display them. And then if I type ls and I scroll to the top, you see, oh, okay, so it's not displaying the hidden ones. Hold on, let's do -A for all. And now I scroll to the top. So now you see .anaconda, .android. So it's the same listing, only this is with text. If I did that a little bit fast for you, it's ls space -A. It's pretty typical in a terminal environment to have a command whose name is something like this, but then the command has different parameters that control its functionality. And usually you specify those starting with a dash and then a letter that controls what the functionality is. So here, ls space dash a. These are sometimes called flags. I want to make a new folder that I can create my source code in. I'm just going to create it inside ddobrovich here. So if you were using the graphical system, you could right click and say new folder. Instead of that, I'm going to use the command line. I'm going to say mkdir, which stands for make directory, and I'm going to call this Java Hello World. It's conventional not to have spaces in your name here. If you do put spaces, it's going to think you're trying to create several things, and it's not going to be able to. If you really want to put spaces, you can do this, and that will make a folder whose name has spaces in it. But pretty much you just shouldn't do that. So Java Hello World, and now it's done it. And we should be able to see it updated here. So if I scroll down, I might have to, oh, here it is. So this is the one we just created, Java Hello World. If I wanted to go inside it here, I would double click on it. Here, use another command called change directory, because remember, directory means folder. The command is abbreviated CD, and then I type the name that I want to go into, so Java Hello World. And here I am. And you can actually see that it's displaying a path. This tilde is shorthand for your user home folder. So I'm saying start at my user's home folder and then go into Java Hello World, and that's where I am right now. If you want to go up, so if you want to sort of, if I clicked here, that goes up to ddobrovich. So now I went out of the folder back to ddobrovich. You can do that here by saying change directory space dot dot. Dot dot is what takes you up one folder. And so here I am back in ddobrovich. If you don't like all the typing, this terminal has autocomplete, so you can type cd j tab, and because there's only one folder that starts with a J, it's completed the rest of the name for me, and I didn't have to type it. All right, so here I am back inside the folder, and there's nothing there. So let's create a Hello World source code. Rather than using an IDE, let's use a plain text editor. Even though I told you I didn't like Notepad, let's use Notepad because it is so minimal and it's really obvious that nothing fancy is happening. So let's type public class Hello World, and then I'll open and close some curly braces. And then I'll type public static void main string with a capital S and 2 brackets, args, open bracket, close bracket, and then system.out.println hello world with a semicolon. Okay, it is moderately likely that without the help of an IDE, you may have made a typo here, and you'll see, actually, let me have some typos on purpose. So I'll have a lowercase s as a typo on purpose, and we'll see what happens. But let's go ahead and save this. Let's find... Can I type? Okay, so I'm going to type C drive users ddobrovich. Great. And then here's Java Hello World. So I've gone to the same folder that I was in. It's very important that you name your file the same as your class name. So my class name was Hello World with a capital H and a capital W, so that's what I'm going to name it. And I'm going to include .java at the end. It's still a text file that only contains text. Having the .java file extension is just a way for us to mark that this text file contains text that is Java source code. Okay, so I saved it, and then if we type ls here, we can see that it's there. And here, if we go in, we can see that it's here also. So lots of ways of verifying that our code is there. You can actually look at the contents of the file inside the terminal using the less command. So if you type less hetab, there it's displayed the text file. You type Q to exit. So let's go ahead and do the first step, which is trying to compile this into a class file, which then you would run afterwards. So we'll run the Java compiler, javac, and then you just give it the name of your Java file. And this you might recognize as the kind of error that it displays down in the terminal when you're, or sorry, down in the console when you're in your IDE. Usually it's all in red. So it's saying hello world.java. This is line 3 is where the problem's happening. And it's trying to tell me what the problem is. It says package system does not exist, which is not terribly helpful. It's sort of come close to where the problem is, but really the problem is I didn't have a capital S. So let's go ahead and change that. Here I'll make this a capital S, and I'm going to save it again. And now I'm going to rerun the program. Oh, by the way, you don't have to type Java C. You can hit the up arrow, and you can scroll through all the previous commands that you've run. The down arrow will take you backwards. So if I just want to run the same command again, I'll hit the up arrow once and then enter. You see that it didn't say anything, which usually is a good sign. If there was an error, it would have said something. And over here, you can see that it's added another file called helloworld.class. In the terminal, we'll type ls to display, and you see there it is again, helloworld.class. So that's the compiled file. If you want to see what the compiled file looks like, you can still view it using less. So we could type less helloworld.c tab. I'm hitting tab to do the tab of completion here. And it's warning me that it might be a binary file. That means that it's not text, it's a compiled file. But that's fine, so I'll type yes to see it anyway. And this is what it looks like. This is not displaying the zeros and ones of the binary. It's interpreting all of the binary bytes as if they're characters, and some of them are printable characters, as you can see, and other ones are not printable characters. If you wanted to actually see the bytes or the bits themselves, you would load this in like a hex editor, and that's a special editor that will let you see the numbers directly. Okay, time to run the program. So remember, we have helloworld.class, so you type Java and then hello world, but you don't type .class, you just type hello world, the name of the file with no file extension. And there you see that it's run. If I tried to run, for example, my source code, helloworld.java, what would it say? It says, could not find or load main class helloworld.java, because the JVM is trying to run a compiled file. You can't run a text file directly because you have to translate it into this Java bytecode first, and that's what the class file is. Excuse me. So the command line is pretty great, and I think it's fair to say that every programmer worth their salt knows how to find their way around the command line. Most shells also have their own programming languages, so you can program directly in the terminal here to automate certain commands that you might run. If you're interested in learning more about some basic use of the terminal, I'll provide some links to some stuff that I've made, and then of course, you know, the internet is full of all kinds of other information. Just for fun, let's do something totally unrelated, but that's easy and interesting. Type ping and then some URL that you're interested in. What this is doing is this is sending small packets of information to whatever IP I got routed to when I tried to go to www.google.com. And what it's measuring is it's measuring how long those packets of data took to go to the server and then return to my computer. And so you can see that it sent 32 bytes and it took 14 milliseconds. So usually you use ping as a basic way of testing connectivity. Let's do another fun one. Let's make this bigger. So traceRT stands for trace route or trace route. And let's do the same thing, google.com. This command will trace the sequence of computers that a packet travels through as it goes from my computer to the Google servers. So you can see here's me, and then it goes to Tower 3, and Sail Internet is my internet service provider. So it went from my computer to the internet service provider, and then through some intermediate servers here, and then it ends up at, it looks like SFO, so San Francisco office, maybe. Seems like it's the Google server. So again, there's a lot of like interesting built-in low-level tools that you can access through the command line that you might not otherwise know.